Good morning, and once again, welcome to Code with IJ. And we're going to continue our series on tips from Pragmatic Developer Andrew Hodge, and we're at tip 46. We still have a long way to go, but don't worry, we're going to get to the end of the series very soon. So tip 46 says don't program by coincidence. Most of us, when we are working on a task or we're building a particular project, there is this particular popular developer code that says when it works, don't touch it. But apart from it working, try to understand why it works. It's very fundamental for a future aspect of when that code start breaking. If you don't know why it works, you might just go a very long way removing things from the code, trying to like sort the problem that isn't even the problem at the first instance. So don't program by coincidence. Don't just pack a bunch of code and put it into your code base and don't understand line by line what those codes execute when they run. Why do they execute that aspect? So oh, am I working in alignment with the business need, or am I working blindly? So this tip actually help you to gauge your performance level, and at the same time it help you to grow and develop as a good developer. So estimate the order of your algorithm. Like when I saw this particular tip, estimate the order of your algorithm, even though I have read the book, I was still a bit conflicted about what it means. Say before optimizing your code, know roughly how fast or slow your code is likely to be. Most of us don't check about the response time of the functionality we are implementing. For instance, database is one of the bottleneck of every application, and most developers don't really look about the logic they're writing. Most time we are doing a lot of select, or we are doing a lot of nested coding, and that alone would would be a big bottleneck to the database optimization. And when it's a big bottleneck to the database optimization, it leads to poor, slow performance of your system. And when there's a slow performance of your system, it leads to frustration of the users, because just imagine a user is trying to create a form, and for them to get a list of countries, it's taking them 2 or 3 minutes. That alone is very, very frustrating, because most times they will have refreshed the page 4 or 5 times, and that slow network latency, it's causing a very, very slow issues in your system. So try to understand the order of your algorithm, that if I put this algorithm in place, how long will it take for it to run? What will this algorithm cause the other modules or the other functionality? How well will it play with the other things in the system? Is it going to break things? So you have to really, really be very careful of each line of code you add to your code system. So you don't need exact time. You just understand the order of the growth. Like, is it a O1, O2? We all know big O notation. If you're using a list, so all these things is what you are supposed to know. So all these things are what you're supposed to know in order to develop properly, so that you don't just develop to fit the business need, or you develop um to improvise the test case, or you develop so that everything runs well in the system, but the performance level of everything is very, very slow, or the scalability is not being put into place. So tip 48 say refactor early, refactor often. So many of us, whenever we code or we write a logic and we find out a better way to do that logic, we don't even want to go back to that code. We say, oh, it's working, well, let me just leave it there. And when something starts crashing because of that logic you write, you not go over there and the whole code look messy. A clean code is going to save you a long time of refactoring. So refactor early, refactor often. Make sure that you always go back once you're working on a module. Check, always streamline your other code, check your code, check that logic, and if you see a better way to write a functionality, you do. Don't feel like it's too much work. Go back and refactor that code. The earlier you refactor your code, the better for you. So don't try to refactor and add functionality at the same time. So many of us, when we are refactoring a logic, at the same time, we are trying to implement a new logic into that same code base, and that could lead to it the whole system crashing. So your refactor code could be in a different branch. When you refactor that code and you see that, oh, the code I refactored is working, then you can add a logic to that particular service, but don't add logic and refactoring at the same time. Instead, you might just have a messy playing ground over there in your code system. Tip 50, which is the last tip for today, is one test before refactoring. Run tests as soon as you start refactoring. So many of us don't like running manual tests, rigorous testing, unit testing. We don't even want to test the code. All we want to know is that this code is working. Like you have 100% confidence in your code. Where did that confidence come from? I have confidence in a tested code, a code I have tested manually. I've written unit testing for. I have solid confidence in that code than a code I just write and I did only manual testing for, because in unit testing you cover up some test cases you might not have cover up during the manual testing. And when a test idea comes to your head, try to implement it, try to add it into the test case, because that test idea that is coming to your head is actually fixing a logic that you might not be aware of. So code safely, code smarter, and code smoother. And once again, thanks for joining this channel. Thanks for sharing, and thanks for all your likes and all your love. Thank you so much, and we really appreciate. Let's build smarter. Thank you.